Perfect. Yeah, whenever you're ready. A couple of weeks ago, something incredibly important to us was taken away from us. An hour of sleep. Yes, I'm in fact talking about daylight savings. But do we all remember waking up that morning feeling a little extra tired, a little extra groggy? That's primarily because our body has this internal circadian clock, which is made up of a bunch of proteins that you can see in figure 2 there. And this clock was suddenly exposed to a completely new cycle of sunrise and sunset, which is what led us to feeling a little tired. Now, while this is a very minor behavior outcome of a slightly imbalanced circadian clock, if these kinds of imbalances are chronic, like in case of shift workers, new parents, or grad students, much more adverse health outcomes can be observed. Therefore, I say as a grad student, it's imperative that we learn everything that there is to learn about this clock. My research question tries to answer this fundamental question that can be applied to any clock out there. Where do the parts of this clock come from? Our circadian clock is made up of a bunch of proteins. Where do these proteins come from? To answer this question, I look at where everything in biology comes from. Our DNA. Our DNA has the code written to make the proteins in our nose, our eyes, our hair, and our circadian clock. And to look at our DNA, I use this specific technique called a tag-seq, which is a combination of biochemical and computational analysis, which allows me to take a piece of DNA, scan it, and look for footprints of all the proteins that are sitting on it. Footprints of protein on a piece of DNA, what does that even look like? Well, I'm glad you asked. In figure 3, you can see those 3 red peaks. Those are footprints of different proteins sitting on that piece of DNA that makes the protein clock, which is what I'm interested in. And by currently doing more computational analysis, I'm trying to figure out what the what the proteins are that have those specific footprints. This is not very different from us going to a beach, identifying a footprint, putting our thinking hats on, and asking whether it's a footprint of a cat, or a dog, or a human being. The only difference is I'm doing this with proteins sitting on a DNA. Now, understanding where all of these circadian proteins come from is so crucial because at a molecular level, this allows us to identify drug targets and therapeutics for folks who are already suffering from chronically imbalanced circadian health. Years of research has shown that improving your circadian health can improve all aspects of your lives, including healthy aging. Therefore, the goal of my PhD is to try to identify the start switch for where all of these proteins are coming from so that we can all live happy, healthy, long lives and attend many more 3MTs in the future. Thank you.